So one thing I would recommend you to do is maybe have a pen and a piece of paper, because I'm going to be mentioning some of the best practices on how to set up mathematical modeling. These practices are going to help you throughout the term. So what I suggest is, as we talk through this, please take the key notes that you're going to learn from this webinar. The first thing that I want to mention is, and that was brought up in the discussion board, is the idea behind modularity. And modularity is when you have this information given to you through the exercise. You see, when you click this link, Open Table as Spreadsheet, you get this information in Excel format. Now you have the input information from the exercise. Now, the next thing you do automatically is you start building the different modules. Decision variables, objective function, and constraints. These are the key elements in any mathematical model. Okay? And the decision variables are the variables that are unknown. We don't know these variables. Neither you nor myself are able to come up with these variables. Who needs to come up with these variables? The solver utility. That's why we use solver. Okay? Now, with that being said, we use these decision variables to come up with the optimum solution. When we say optimum solution, we're talking about the objective function. The objective function is what we're trying to maximize. This is what we're trying to optimize. And it could be cost, it could be profit, it could be efficiency, time, you name it. Resources, people. So these are the things that we're trying to optimize. We call that objective function. We also call that the target cell. You'll hear two different names for that. Decision variables, these are called also the changing cells. So you could learn these terminologies as we go on. And when we talk about the objective function, what we're trying to do is two things, or three things: maximize, minimize, or set to target. When we say maximize, obviously we're talking profit. When we say minimize, usually we're talking cost. Also, we could say maximize efficiency, minimize maybe lead time or time, right? We're not going to use, throughout the term or this course, we're not going to use set to target. So ignore this one. Just focus on these two, maximize or minimize. Okay? Anytime you hear maximize, you're going to know it's either have profit or efficiency or utilization, you name it. These are things that you use on a day-to-day at work, in your life. Kind of. Sorry, there's some noise. There's some background noise. If you could please mute your speaker. Okay, good. That's better. All right, so I'm going to delete this stuff. Could you please mute your speakers? I'm hearing some background noise. Until you want to say something, then you can unmute. All right, thank you. When we talk about the constraints are the requirements. Those are the constraints, things that we have to fulfill. Something that is mandatory. So these are things that we have to comply with. We call those constraints. And when we talk about constraints, there is what we call left-hand side, there is the symbol, and there is the right-hand side. Right-hand side is where the constraint is. The symbol, it could be less than or equal, greater than or equal, or equal. These are the symbols we're going to be using. And the left-hand side is what we're trying to calculate. This is based on a calculation. Based on a calculation. All right? Can you have just one constraint? No, you can have constraint number 1, constraint number 2. You can have multiple constraints. Can you have multiple decision variables? Yes, you can have decision variable number 1. So you can have multiple decision variables. Okay? So this is, can you have multiple objective functions? Well, in our case, no, we're not going to have, in this course, we're not going to have more than one decision variable, one objective function. So this one is only one objective function. So 1. This would be multiple. And another thing you need to remember is this is based on a formula. And it should have the equal sign, whatever the formula is. Okay? And that formula ties back to these decision variables. We'll talk about that as we do some exercises. So these are things that I would like for you to remember, and we will touch base on those as we continue with the next modules. So for this exercise, as you read through the exercise or as you read through the textbook, don't read it like you're reading a novel. This is mathematical modeling. It does require, having a pen and piece of paper as you read through things. Try to remember the terminologies being used or portrayed to you. Try to understand the concepts. We're going to be touching on more difficult things as we continue through this class. But one thing I would like to emphasize on, the only way you can understand mathematical modeling is through practice, practice, practice. And remember that. You'll have to practice multiple examples. For this one particularly, what are we talking about? What we're looking at is the allocation model. I don't necessarily agree with this exercise being brought to you in Module 1. Reason why? Because some of the concepts will be touched on in the next modules as we get into the linear programming. The allocation model, or the allocation of plant output, it is an allocation model. It is one of the models of linear programming. What we're trying to do is, I'm going to read through this. A firm owns 5 manufacturing plants. These are the plants that are responsible for the quarterly production of an industrial solvent. So what we're talking about is production of the solvent. The production process exhibits this economies of scale. At plant P, the cost of making X thousands or 1,000 pounds of the solvent is approximated by the quadratic function. So this function, so the f of x, it represents cost. X represents thousand pounds, or pounds in thousands. I would put it this way. This is how I read this. The parameters CP are plant dependent. So we have the CP, which is plant dependent. What is CP? Well, it's given to you. This is the parameter CP, so that's what we consider the parameter. And every time we talk about a quadratic function, I'm not going to get into the algebra or the geometry. Quadratic function is truly something that helps you create that concave up or concave down parabola, and that is the function that represents that. So with this being said, they're asking the quarterly volume requirement is 50,000 pounds. Here, what I see, when I see requirement, I know they're talking about constraint. So the question is, how should production be allocated among the 5 plants in order to minimize the total cost of meeting the volume requirements? So what I'm looking for is the production allocation among the 5 plants. To what? To minimize the total cost. So automatically what I know here is I'm trying to figure out 5 decision variables, because how should production be allocated among the 5 plants? What I do as part of the best practices, which I want you to follow this strategy going forward, is try to highlight the decision variables in a certain color. Okay? This tells me that these cells are dedicated to the decision variables. Am I supposed to come up with those decision variables? No. That's not my job to do that. That is the solver job. So this represents what? This, I can even write above each cell pounds at plant 1 and do the same for the rest. Right? But I'm not going to do that. I already know this is talking about the distribution across the plant, how many pounds that I need for each individual plant. To what? To minimize the total cost. So this one here, we're talking about cost. I'm going to give it a different color. Okay? So what we're saying here is we're trying to minimize cost by finding what's the distribution of pounds per each or for all the 5 plants. What is my constraint in this case? I have one constraint. The quarterly volume requirement is 50,000 pounds, meaning that I can easily write this. Again, left-hand side, I have the equal symbol. That is the symbol that I'm using, because they're saying here the quarterly volume requirement is 50,000. It's not less than or greater than. It is 50,000 pounds. So what I'm going to write here is 50 or 50,000, whichever. If you scale it down to, at a 50,000 or maybe 50, it doesn't matter. I will basically, accept any of those solutions. So I know the requirement is 50,000. But what if this is my right-hand side? This is the constraint. This is my right-hand side. I have my symbol. What is my left-hand side? So let me take this up here, just one. What does this represent? We know this is a formula. What does it tie? It ties all of these, the sum of all of these, whatever the solver comes up with, have to be equal to 50,000 pounds. So I fulfilled my constraint requirement. The quarterly volume requirement is 50,000 pounds. The total requirement is equal to 50,000 pounds. Now, how do I calculate my cost? Remember this? Cost is based on a formula, which takes what? So what I can do, and this is part of your mathematical modeling, is do a few calculations prior to solving for your objective function. Here the calculation is cost at plant 1, cost at plant 2, 3, 4, and 5. And that is based on a formula. The way I would write this is equal to, and I'm just going to write the formula as is, 1 divided, but I'm not going to use the symbols CP or X. Of course, I'm going to tie CP is this one, is my parameter for plant 1. I'll put the parentheses. As you can see, the numbers I'm using are different from the one in the textbook. Reason why? Because I'm not going to be giving you the seconds, otherwise there is no point. Times, what is my X? Is the pounds and thousands. And that is what I'm trying to solve through solver to the power of 2. That's it. That is for plant 1. Plant 2, plant 3, plant 4, plant 5. So I have my formulas ready. These represent the different costs of all the plants, of each plant. Now this one will be a sum of all the costs. Before we get into the solver, I would like to open room for questions. So if you have any question, please either let me know through the chat room or let me know through the phone. So we'll see how that works. So I'm going to be reading your chat room chat messages as you send them. If there are none, I'll give it just 2 minutes. If there are none, I'm going to continue from there. Any questions so far about what we just covered? No questions yet. Okay. How do you get the sum formula? The sum formula, if the recording works out pretty well, I'll be posting it on the discussion. Hopefully it will take the size of the 1 hour recording. But the sum, all I did is put in a sum of all the costs. So remember, there is a prerequisite to this course, which is the Math 240. So the expectation is you need to be really familiar with these f of x, x. So we're not going to cover those in details. Hopefully you're at that level where you could easily go through those and figure those out. The functions, the quadratic functions. If you're not, please do your research, and hopefully it will start becoming much easier for you as we move forward. All right, so I'm going to go ahead and move on with this exercise. So now it's time for the solver. I'm going to move this stuff here. I have everything set up. I have my change in cells. I have my calculations to help me figure out what the total cost is. And I have my constraints. I have my constraint here on the right-hand side, and I have the left-hand side taking the total of these. The sum of all the decision variables has to equal out the 50,000. Did I miss anything? I don't think so. I think I have everything set up right. Now I go to Data tab. I fold Solver. And here's how these colors tend to help me plug everything in Solver. I know for setting the objective, I know it's the one value in green. I can just highlight this. And I know for the change in variable cells, I know these are the change in variable cells, like we talked about. But remember, before I jump to this, a lot of people tend to forget to select the right method. And here we're not talking about maximizing costs, we're talking about minimizing costs. And as I mentioned, these are the only two that you'll be using in this course. The change in cells, you see what I do is I click this, and then I go and select the change in cells, my yellow cells. And then this is the section for the constraints. I click Add, and I go with this, and I click my left-hand side. And I go back just by clicking this again. Then I change my symbol. and you could see the different symbols. We're going to touch on most of these in the next modules. But we're going to select equal. And then for the constraint, we're going to select the right-hand side. And once we're done, if we have more constraints, we can click Add. If we have only one, we can click OK. Make sure you keep everything that is, and then we hit Solve. Before I hit Solve, I want to mention to you that in the next module, or the next two modules, you're not going to be using the nonlinear, you'll be using the simplex linear programming. I just want to put that between parentheses because it will help you do the next modules properly. So for this one, that's not an issue. We'll just leave everything the same, and we'll just hit Solve. All right. As you can see, Solver came up with this distribution. This is how Solver took this 50,000 pounds and distribute that across the 5 plans to come up with the minimum cost possible. The one way I know that I achieved the optimum is by looking at this message right here. It says, Solver found a solution. All constraints and optimality conditions are satisfied. If I get a different answer than that, then I know there is a problem with my Solver setup. I'll tell you one thing, though. Maybe you could also remember this. If Solver says it has converged to a solution or something of that nature, when you hear the word converged, that means Solver approached the optimum solution, but it hadn't achieved the optimum solution. What will you do in that case? You will just have to click OK and rerun the Solver, just like go back to the Solver and hit Solve. But at this point, everything seemed to be fine. There is no point of rerunning the Solver. What you do is, best practice is just keep Solver solution. Don't go to restore original values. Just keep Solver solution. Click Answer to generate the answer report that we talk about, and then hit OK. So keep Solver solution. Make sure you have this message saying Solver found the solution. All constraints and optimal the conditions are satisfied. Select Answer Report and hit Answer. That is the answer report, and this is your mathematical model. We'll make quick formatting to make these representing cost. I don't care for the decimals that much, unless if they're required. And this one here, I'm just going to remove some of these decimals and look at this. If there is any question being asked, let's say 1.5a, I can just write it down here and say the answer is blah, 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 blah. 1.5b, and so on and so forth. The answer is, sometimes you might have to create a sheet for 1.5a and another sheet for 1.5b, but that is not the case here. We don't have any questions being asked other than setting up the model. So at this point, your model is complete. So let me go back and see if there are any questions in the chat room or any questions being asked on the phone. So I got one question here. If Solver is truly looking for the minimum, why wouldn't it put all 50,000 in the cheapest plant. Nothing within the constraint says use all plants. I'm going to answer this one very quick, Derek, since it really has to do with the quadratic function. And I did submit an answer to you on the discussion board. Hopefully you get a chance to read it and respond back. But in this sense, if you say this is the cheapest plant, let's say it looks like this plant, which plant got the most pounds of solvent to produce? This plant right here. Plant 4 got 15,000, where the lowest amounts get produced in plant 5, 4,545. Okay, good. So what if I do this? What if I take, remember this value, 113,636,364. This is in dollar value. This is what we got as a minimum value using the solver. If we follow your logic and change this to 50,000 and make this 0, look what happens. This is 50. Let me make sure. Yep. 50,000 pounds. We got 357, 142, 857. This is what we consider minimum based on naive. This is what we consider minimum based on optimality. What you're going to realize is with the solver, we don't use common sense. Sometimes common sense is not common sense. Because once we look at things, we just say, okay, well, this is because solver looks at all the requirements all together. That's one thing. And it looks at the formula. In this case, we're not looking at the linear formula. We're looking at a quadratic function formula. And if you can think about a quadratic function, in order to draw a quadratic function, as I mentioned, is that you have to, let me try this. You will have some sort of a, if I can do this right, it will turn out to be, I hate working with the, what I'm trying to draw is a parabola. And with that being said, let's leave this one, since it's a special question, let's leave it till the end. I don't want to take more of people's time, since it doesn't relate to their questions. It's really outside of the, it's a little bit outside of the scope of this, but I do have the answer for you. So stick around after this, and we'll hopefully get you the answer to that. Does anybody have any questions about 1.5? Does anybody have any questions about how to work with solver? I did answer your question, Derek. That's good. So yeah, just think about it as a, I wish I could draw something here, but unfortunately I can't. Let me maybe format this and make it white. Think about this. Yeah. Just think about, how a parabola is versus the X and Y axis. And yeah, we'll talk about this further. I don't want to keep going back. Could you show one more time how you fill in the quadratic function with, sure. Can you briefly go over 1.2? Absolutely. It's like the better you. Yeah, exactly. All right. So one question is, here's the formula for how to do the, you can take a screenshot of this, or you can just write it down very quick. All I did is take in equal 1 divided by CP. I just select CP times, make sure you put it times x squared. So my x is the change in cell to the power of 2. Hit enter, and I just drag this over because I know it's just going to apply to the rest of the cells. Now let's go to 1.2. If nobody has any further questions. All right? So pause sharing. Let me go back and pull some of this information. All right. Very quick. Okay, now I can do resume sharing. Okay. Can everybody see my screen? Sure. So, okay, good. So, as you could see, one thing you could do is maybe start taking the exercise like I do here, or just put it on your Excel file. That way you have everything in front of you. Maybe that's part of the best practices you could learn in this course. So now I have everything in front of me here. Pricing into markets. Same thing. First thing is the inputs from the exercise, the data, the input information. You can call it whatever. You can call it background. You can call it business problem statements, or whatever you want to call it. But once you have that information put here together in this fashion, then you're ready to work your way through the mathematical modeling. Again, we'll do decision variables, or what we call them change in cells. We'll do objective function. It might include some calculation here, some calculations, and then finally whatever that I'm trying to optimize, whether it's profit or cost. Then finally the constraints. So I'm going to just take this one off. All right, so I have my 3 sections here. Then I can read through the exercise and see how I can fit everything together. Global Products has been making an electronic appliance for the domestic market. Demand for the appliance is price sensitive, and the demand curve is known to follow the linear function. So what is D? It's the demand. What is P? It's selling price. Where D represents annual demand and P represents selling price in the home currency, which is the franc. So I'm going to put that as my currency. Let me resize this a little bit. The cost of manufacturing appliance is 100 franc. So cost, I know it's 100 franc. For the coming year, Global is planning to sell the same products in the foreign market, where the currency is the mark. From surveys, the demand curve in the foreign country is made to follow different linear function. And that is why it's important to read through the announcement page, because I try to simplify these exercises for you. Okay? The A section should be on its own sheet, where B section should be at a different tab, just like you see here. They're 2 different models. Sometimes it's hard to tell by just reading the exercise. So please pay attention to the announcement page, to the general discussion. And if you have any questions, please do not hesitate to write it down. It could be as simple as, do I have to have 2 different tabs? Do I have to, use 2 different formulas? It looks like this formula is specifically for the domestic market, where this formula is for the foreign market. Is that right? Things like that. And hopefully one of you guys can respond to the question being asked by your peer, or whenever I get the chance, I'll respond to you, knowing that there are so many questions being asked throughout the week. So here in this case, what are we looking for? All production will be carried out at Global's domestic plant. We are producing at the domestic plant with the expectation that the unit cost will remain unchanged. The exchange rate is 1.5 mark per franc, and Global plans to offer an equivalent price in both markets. If Global were to operate exclusively in its domestic market, what would be its profit maximizing price and its annual profit? This is so profit maximizing price. So we're talking about profit. And we're talking about selling price as being the decision variable. What would be? So the unknown is what would be the profit maximizing price. And then the objective function will be what is the annual profit. Are there any constraints? In this case, there are no constraints. So the way we've set this up is I'm using different values so that I don't give you the correct answer. One concept for all of you to learn is if you're not familiar with it, is the price elasticity of demand. Yeah, price elasticity of demand. This is a good concept. Once you increase the price, the demand goes down. Once you decrease the price, the selling price, the demand goes up. There's a negative correlation there. And that is the concept of the price elasticity. In this case here, you have a linear function. So in order to set up that function properly, you set it up in this way. So you have production cost is, in this case, is 100 right here. I put 150. What we have for the demand is based on a formula. So the parameter A, here is 4,000, I put 3,000. Parameter B is -5, I put -3. Okay? Some people like to put the positive number, and then when they try to put the formula down, they throw that negative symbol in there. Sometimes people like to put -3 as the parameter B, and then in the formula they put plus -3. Whichever way you do it, that's fine. Just make sure you write the formula properly. So, what we know, before we calculate profit, we know it's based on what? You can put it in this fashion. What is revenue? And what is cost? And profit is revenue minus cost. So I can put it in this fashion. But before, let me make sure I follow my exact same best practices that I always do. Trying to find the selling price, and I'm trying to figure out the profit. There's no constraints involved. So in this case, I can even put my demand here if I want to. Sorry. Demand is going to be based on a formula. So which is this minus this times this. I have my demand. Revenue is equal to what? Revenue would be the demand times the selling price. Cost will be the demand times the unit cost. Profit will be revenue minus cost. Of course, it shows a negative number until this populates. So this is how to set up the model before you run Solver. Any questions so far? So as you see, what we're trying to do is figure out what are we looking for and what are we trying to maximize or minimize, and if there are any constraints. These are the first few questions you ask. Once you clear that out, then you say, okay, in order to maximize profit, do I have to do any further calculations? You can embed everything within this formula without having to do all these calculations. You can say, you know, I'm going to create a huge formula altogether, put in revenue here, then minus cost here, all together in one formula. But I like to put it in this fashion so I make my model clear, because there are some models that will take a lot of different variables. So you want to simplify it as much as you can. So let me read through the questions, if there are any. What was demand? Demand is based on the formula. Remember, sometimes what you're going to get from the exercises are some deterministic values, some values that are known, like this one, 100 francs for the cost. Sometimes you're not going to get a value, you're going to get a formula. All you have to do is set up the formula as you read it. Set it up like you see here. C7, see, I don't write 4,000. I make sure I write it down here as a parameter A, parameter B, and then I refer to these whenever I need. So I do C7 minus C8 times P, where P represents selling price, right here. So it doesn't have to have a populated number here before I can refer to it. I can refer to it anytime. And then let the solver do the work. Now, what am I trying to maximize? So the objective is profit. And I'm going to make sure that it's set up maximize by changing the variable cell, which is the yellow, selling price. And there are no constraints. Whether you add this as a constraint or not, that's not a big deal. At this point, we'll just leave everything as is, and we'll just hit solve. Solver found a solution. All constraints and optimality conditions are satisfied. Okay? And we hit OK. And here you go. So we make sure that this is let me pause this here very quick. And let's make sure there are no questions. Are there any questions? So as you can see, we did a few calculations prior to running Solver. We had to determine what the demand is. we have to determine what the revenue, what the cost, and then from there we determine what the profit is, which is revenue minus cost. The demand is based on a formula. The selling price is what we're trying to figure out. So now, if you're in marketing or sales and you're not sure how to set your price for the product that you're trying to sell, one way you could do this is maybe go and figure out what the formula is. The best way you could do it is just like you do with any regression analysis. Go out there, start selling at a higher price, see how much you sold, start reducing the cost, see how much you sold, start reducing the cost, until you find that trend analysis or that regression equation. Or you can just go out there and figure out how the market behavior is when the price is set high or when it's set low. Once you figure out what the formula is, you can bring it in and say, if I'm trying to compete within that market, what should I set my price to maximize either the demand or to maximize the profit? And the software will help you figure that one out. So that is a good example of that. So, and I've said about 1.2a, and let's see if there are any questions. We'll go to 1.2b. And I'm going to pause this very quick. Just bear with me 1 second. If you could think about a question, please don't hesitate to ask. Because we're not going to go through this again. And if I hear somebody asking the same questions that we just went through, then all right, so I'm going to resume sharing again. Can you see my screen? I think you can. Okay, so for this one, what we're talking about is you are selling in both markets. You are Global Products, Inc., and you're selling in both markets at one equivalent price. So what we're saying is the cost to make the product is going to be the same. Why? Because you're making the product domestically. And it's been mentioned to you here. All production will be carried out at Global's domestic plant with the expectation that the unit cost will remain unchanged. The only thing that they're trying to trick you with is the exchange rate. And what we're trying to do here, again, we know the home or the domestic has this formula. We know for the foreign market, it has a different formula for the demand. And we know the unit cost is the same. I changed the values, so just so you don't see the correct answers. 3,000, 4,000, 3, 5, 1,500, 2,000, 2, 2. Same thing. 80 francs, 100 francs. Exchange rate, the exchange rate. Just slightly different. And now we do the same exact thing again. Decision variables, objective function, constraints. Now when you have this, what is the profit maximizing price? And it's annual profit. So what we're trying to do again is we're trying to figure out profit, maximum profit. Here we're trying to figure out the selling price. Yellow, green. we know the one slightly thing is that the selling price for the foreign market is this times 1.5. That's it. When we sell at this market, in dollars, for example, we have to convert it to euros when we sell in Europe. But in fact, we're selling at the same exact selling price. It's just different currency. So we have to convert. So you convert when you're selling at the foreign market. So there is no point of having two decision variables because you're only deciding what the selling price should be to sell in both markets. The calculation will be closely or relatively the same. You will have revenue, you will have cost, and of course you will have demand. Here the demand for this is different from the demand for this. This one will be what? It will be 3,000 minus 3 times this. This one would equal to 1,500 minus 2 times this. I already have, I hope I have a formula here, equal this times 1.5. Okay. If I change this one to 1, this one changes. Yep. So, fair enough. So the revenue here is equal to what? This times demand times the selling price. This one times the unit cost. The profit, in fact, what I can do, I can find first profit at each market and then do total profit. And I'll make this one green because I have to calculate the profit for each. So in this case, equal revenue minus cost. Here, the revenue is what? Equal the demand times the selling price. This one is equal to demand times the unit cost. It's the same unit cost when it's produced domestically. Now, here's another tricky thing. This one, when we calculate the revenue for the foreign market, the revenue is going to be in marks or marks. This one is going to be in franc. So you can't take euro minus dollars. You will have to convert back. To convert this back, you'll have to divide by 1.5. To get everything in franc. This one is in franc. This one is in franc. This one is in franc, except this one is not in franc. So for that reason, we're just going to make this a converted value. And then we take this value and we divide by 1.5. Now we can calculate the profit as this minus this. And that will give us the profit at this market and the profit at this market. Remember, everything we're doing so far is setting up the formulas, because once we populate this field, everything is going to look normal. Right now, everything looks weird. But just make sure that you are following your logic and your algorithm. Because what you're doing, optimization is truly meaning mathematical programming. So you are writing your program. Think about that. Just like you write a computer program or algorithm, that's exactly what you're doing. So make sure that if you convert something, write it down. Make sure you follow through that. And then the last thing is this plus this will be my total profit. No constraints in this exercise. Am I ready now? Yes, I'm referring back to everything properly. Again, the only thing tricky about this exercise is that in selling price being, this one being in Mark, hope I spelled that right, and this one being in Frank. Yeah. So this is the only thing different. This is the only thing different because this one, it will be in Frank because it's using this. This one is going to be in Mark because it's using this. So you can't take, and this one is going to be in Frank. So you can't take Mark minus Frank. You have to convert this back. So we converted it back to this by dividing by 1.5, and then now we got the value. So data, solver, what is my objective function? It's right here in green. What we're trying to do is maximize by changing the selling price, no constraints, solve. Solver found the solution of constraints and optimality conditions are satisfied. Select answer, keep solver solution, hit OK. I need to sell at a 415 franc, which means it's equivalent to 622 mark in the foreign market for a total profit of this. Of course, this is using my own made numbers. You would have to use these numbers. The logic is the same. Any questions? I think we're running out of time. Oh, 1.3. Very good. It's a great point. 1.3. What I will do instead is I'm just going to select this. 1.3. I'm just going to rerun it very quick, just to make sure. And hit OK. Perfect. Yeah, we had just a slight thing here. This one here, also 1.3. My bad. Rerun. Okay. Oops. That's what we're talking about. It says has converged to the current solution. Just run it again. There you go. See? That was an example of when it says has converged. And I just had to run it multiple times until I find this message. It's the only time when you have to run it multiple iterations before you can get to the solution. Thank you for the correction. What was that? Who spot that one? Brittany. Good job. Great job. All right, so I think we're coming to the end of the exercise. If I haven't answered your question, apologize. I hope this was helpful. And now I want you to take that mission going forward, and hopefully you feel much more comfortable now with Solver. It's going to be a very challenging course. In fact, many of the students that took it before, these are the two comments I got from them. It's the most challenging, the best course ever taken in their whole, academic journey. So I suggest you put a lot of time into this, practice. It will start clicking, and you'll get better at it. So don't wait until the last minute. Otherwise, I wouldn't be able to help you. And the better you get it early on, the much easier it's going to get. If you slack behind and you ignore it, then so no problem. That's good that you're taking one class. You need all the time. So if you have no questions, no further questions, if you do, please post them on the general discussion board. If you don't, then you guys have a good night, and best of luck to you. All right. Bye-bye.